Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is flatten binary tree to linked list. Given a root of binary tree, flatten the tree into a linked list, and the linked list should use the same tree node class where the right child pointer points to the next node in the left and the left child pointer is always null. They have given that right should point is to its next node in the list and the left should point to its null. So this after flattening the linked list, we after flattening the tree, we have the by pre-order traversal should be maintained. So this is the problem. So we can just observe what is happening here. So this is a given tree and this is the flattened linked list. So what is happening here is this one's left is point to its one's right. That is generally this root of left is pointing to its root of right is pointing to its root of left. So one's right is pointed to this 2. Then 2's right should be pointed with this 3. Correct. The 2's right should be pointed with this 3. Then 3's right should be pointed to its 4. This 4. That has happened here. See, 3's right is pointed to this 4. And then 4's right is pointed to this 5. And then 5's right is pointed to the 6. So this is basically what is happening. That is, one's right is pointed to its 2, 2's right is pointed to its 3, 3's right is pointed to 4, 4's right is pointed to 5, and 5's right is pointed to 6. You can say observe, right? So that is what they have flattened the linked list. So what we can do is we can think from reverse order. So what is happening is this 6 is pointing to its previous 5. Then this 5 and 6 is attached. That is 6 right is nothing but the null. So this 6 node is there. This 6 node if we are giving to some recursive call, then 5's next is going to point to the 6. Then 5's right is pointed to the 6. So we have this 5 and 6 linked list. Then 5 and 6 linked list is going to point to its 4. You can see this 4's right is pointed to this 5. Then this 4, 5, 6 are made, and after 4, 5, 6 are made, this 4's right is going to point 4 is going to point with 3's right. So 3's right is 4, 5, 6. So now we have flattened 3, 4, 5 and 6 linked list. Now next we have to attach this 3 to its 2's right. So 2's right is going to point 3, so that 2, 3, 4, 5, 6 has flattened, and similar way one's right is going to point to 2, so that we have flattened the 1, 2, 3, 4, 5, 6. So while doing this recursive order, what we are doing is this 6 right is pointed to null, right? 6 right is pointed to null since there is no node. Then 6 left is pointed to null. That is always the left should be null. They have given in the question itself left child pointer is always null. So what we are doing is we will just write what is happening. Consider this root is 6. So root right is pointed to null. Then root's left is pointed to null. This is what they have done. Root's left is pointed to null. Then this 6 is passed to this recursive function. That is passed back. 6 is nothing but our current node, current root. So root is passed to some 5, so that this 5's right will be get attached to this 6. So what is happening is now the 5's right should be pointed to this 6. So we have pointed 5's right, root of right as null, but root of right should not be null. It should point to some previous, where previous node is going to be initially null. We can make it as this tree node star previous is pointed to null. So my root of right is previous and root of left is null. We will first traverse the list, traverse the binary tree. There is only two way. Either there is only 3 way. Either we can go pre-order, post-order and in order. If my root is null, we can just return that root itself. So we have to first go to its right, then go to its left, and then we are returning this node. Then it's right, then it's left, then we are returning the node. So what we have to do is we have to do reverse pre-order. So first we will call flatten of root of right, then we will call flatten root of left. After we are calling this two traversals, we have went to its root of right and this root of left, and we have got nulls. Then we are attaching this root of right to this previous 6. Right is nothing but previous is initially null. So then 6 left is always null. They have said the left child pointer is always null. Then what we are doing is we have to return this some way or the other. We have to return this 6 to the next recursive call. That is while backtracking, we have to return this 6 to this 5. So how we can do is we can just change previous is nothing but my root. So if we have done this, now my previous will be pointing to 6. Now now we will be while backtracking, we will be at the node 5. Now the 5's right is nothing but this previous, 5's right is nothing but this 6, and 5's left is nothing but its null. So we have attached the linked list 5 and 6. Now we are making the previous as root, that is root as previous. So root is nothing but 5. So now my previous becomes my 5, and we have backtracking to this recursive call. From this recursive call, we have made the right recursive call. Now we will be going for its left, and then again right, and then this 4 will be going, 4's right is null, 4's left is null, this 4 becomes previous, and then this 4 gets attached to this 5. I think hope you got the understanding. So let us run the code now. So sorry, this is not void function. We are just returning. So it got accepted. Let us submit our code. It got accepted. Hope you like this video. Let me know in the comments. Since I have not used any drawing pen or board, it may be difficult to understand, but see, once again you may get understand what I'm trying to say. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.